Tatanggalin ko pala to. Okay, so our lesson for today is about current and resistance. Ayan. So, pag sinabi natin kasing current, so we can think of other other things related to current. Okay, pero basta pag sinabing current in engineering or science, uh, we mean that something is moving like sa current sa tubig. Ayan. So dito sa subject natin, ang current natin ay yung kuryente or electric current. Okay, so pag electric current ang pinag-uusapan, so yung nagmo-move ay yung charges. So charge yung nagmo-move. Pag may nag-move na charge, yun ay tinatawag nating current. Okay, so we'll also add a resistor, which is an additional element, is an element sa mga circuits natin. Okay, and then also yung energy ay na-transfer through electric circuit. Ayan. Because of these charges, yung energy ay nata-transfer. Okay, so more on electric current. So ang electric current is the rate of flow of charge through some region or space. So when a charge moves, ayan, sabi nga yan, flow of charge or rate of flow of charge with respect to time. So that means yun ang tinatawag nating current. So halimbawa, yung lightning ba ay may current. So may current yon kasi yung charges nag-move sila from the sky. So nag-move sila papunta, let's say, sa ground. So since nag-move sila with respect to time, so merong current na nangyari or merong nag-i-exist na current. At ang unit ng current natin ay ampere at ang ampere ay 1 coulombs per second. So generally, ang symbol natin na current na I ay equal siya sa Q over T, which is the total charge over the total time na nag-move yung mga charge na yon. Ang symbol natin ay I, you think of it as intensity. Okay, not C. So ang symbol natin for current is I. Okay, you think of it as intensity. So meron din tayong dalawang type ng current, yung average at saka instantaneous. Pag average naman, so let's say charges are moving, let's say in this direction to the right, at dumadaan sila sa isang cross-sectional area na A, so yung direction ng current natin is to the right. So if you want to get the average current, so that's equal to the total charges passing through this cross-sectional area over a total time. So yung total time na involved at lahat ng dumaan dyan na charges with respect to that total time. So that's equal to the average current. So consequently, Q final minus Q initial is equal to T final minus T initial. Okay, so that is for our average current. So yung instantaneous current naman natin, so kamukha lang siya ng instantaneous velocity. So that is the limit of the average current when delta T approaches 0. Or that is the first derivative of the equation of the charge with respect to time, dq over dt. Okay, so that is our instantaneous current. Now for yung sa direction of current, ayan. So yung direction of current, depende yan doon sa charges natin. So in the conventional flow or conventional direction, it is a sign that we follow the positive charges. So yung movement ng positive charge, yun yung magiging direction ng current. So that is when it's kino-consider natin a conventional flow. Okay, so that means let's say we have a battery and then we have wire. So yung battery natin, so may polarity siya na positive, negative. So yung charges natin ay nagmo-move sila from positive going to the negative. Kasi positive, positive, the force is repulsive. So tendency is itutulak ng battery natin sa point na to yung mga positive charge papunta sa kabila na negative. Because negative to positive is attractive, kaya hinihila naman sila sa kabila. Okay, yan yung conventional. Pero syempre, in reality or in actual, yung negative yung nag-flow or nag-move, yung mga electrons yung nag-move, na tinatawag nating electron flow. So yun naman talaga yung actual. Pero conventional yung sinusundan pa rin natin or ginagamit na yung mga positive charges yung nag-move. Kaya sila yung sinusundan natin direction ng current. Yung mga direction ng positive charges pag nag-move sila. Okay, so yung mga motion ng mga charges natin, ayan. So in random silang magmo-move. So let's say nasa conductor sila, since madami sila sa isang conductor, lalo na kung solid 'yan, 'di ba? Alam niyo naman yung composition ng mga solid or yung paano yung structure ng mga molecules or atoms sa isang solid. Since compact ang mga 'yan, so yung motion nila is in random. Ayan, random yung motion ng ating mga uh, charges na tinatawag nating charge carrier. So yung mga nag-move na yan, na charges from one point to the other, yun yung ating mga charge carriers. Okay, in the presence of the field, yung electric field, so yung electric field yung magpapamove sa charges na yan. Yung mga batteries, they do not actually supply charges. Nagsusupply lang yung battery ng electric field. Yung electric field na yon, siya yung nagpapamove dun sa charges at yung motion ng mga motion ng charges natin ay from higher potential, a higher electric field magnitude papunta dun sa lower electric field magnitude. Or yun susundan nila yung mga direction ng electric field. Ayan. So, in the presence of this field, in spite of all collisions, the charge carriers slowly move along the conductor with a drift velocity. So, we call the motion of the charges in the conductor drift speed or drift velocity. So, yun yung tawag natin sa motion ng charges. Okay, so, ang motion ng mga charges na to ay mabagal, sobrang bagal. Yung drift speed is mabagal. Kaya kung naka-compute kayo ng let's say 1 meter per second, masyadong mabilis yun. So, probably your answer is wrong. Okay, so dapat yung mga motion nila ay sobrang bagal. Let's say times 10 raised to negative 3. Yan. So possible na yung speed or drift speed ay ganoon siya ang value. So ganun lang yung value. Kasi mabagal talaga yung motion ng charges. Okay? Pero class, di ba pag sa ilaw, let's say, ayan, meron akong switch, tapos may wires ako dito and then may ilaw ko. Bakit pag tinurn on ko yung switch, agad naman umiilaw, but we're saying na mabagal yung charges. Mabagal sila, pero bakit pag sindi natin ng pindot natin ng switch, nati-turn on agad yung ilaw? Yung bagal is let's say 10 times 10 raised to negative 5 meters per second. Bagal pa sa pagong. Kung pwede kong i-compare yung dalawa. Kasi 10 times 10 raised to negative 10, ganon, yung speed. Parang 3 oras hindi man makaka 1 meter. Material of wires, may effect. May effect ba yun? Yeah? Yes? Okay, so, saan naman tanong ko? Bakit pag, since mabagal yung mga charges na to, bakit pag sindi ko nung switch or pag turn on ko ng switch, automatic, di ba? Okay, class. Halimbawa, may charge ako dito malapit sa switch. Siguro, sir, dahil meron ng electricity, sir, tapos yung purpose lang ng switch dahil binablock lang niya. Sir. Okay. Wala. Actually, yung switch ay binablock nga niya. So, ibig sabihin, sa isang side, wala talagang motion. Oo, di pwedeng mag-move. Okay, so ang ano kasi ay class, di ba mabagal sila? Pero, di ba, hindi mo naman iintayin, let's say yung charge dito, hindi mo naman iintayin yung charge dito sa tabi ng switch, particular charge, para pumunta doon para sumindi. Di ba solid yung wire? It means marami ng charge dito sa along the wire at meron din naman charge dito sa tabi ng ilaw. So once na sinindihan mo, kailangan mo na ng konting tulak. So pag nag-start ng mag-move yung mga charges dito, automatic naman na yung iba doon ay nag-move na. So parang meron na agad nandun nakaabang na mag-move na. Once na sindihan to, mag-move na agad. Pero kung itong particular charge ang hihintayin mo para pumunta doon, it will take like days and even years para mag-travel lang isang charge ng let's say 10 meters. 10 meters lang ha. It will take days and even years para mag-travel yung particular charge sa wire na yon. So hindi mo naman kailangan na hintayin pa yung charge na yon kasi solid yan, yung mga molecules or yung mga atoms ay compact at madami sila dyan. So kailangan mo lang ay konting ano lang, mag-move na yung nasa unahan niya. Okay? Kahit mabagal yan. Meron namang nauna sa kanya. Okay. Ayan. Sabi niya, the electrons are already in the wire. So, they respond to the field set up by the battery. So, automatic naman, since may charges na nandun, hindi lang sila nag-move. So, once na meron ka na-open mo na yung switch, doon na sila magre-react at mag-move na sila. Okay? Ayan. Okay, so let's have the general formula and review lang. So generally, ang current natin is Q over T. Average is delta Q over delta T. Instantaneous is dQ over dt. Okay, ngayon, ano ang current natin? Bakit nandito na ako? Nandito na ako agad. Parang may kulang. Hindi nawawala yung page 4 ko. Dito muna pala ako. Okay. So yung speed na yan or velocity, tinatawag natin siyang drift. So anong relation ng drift? Oh, that's a good question, Kyle. Bakit hindi ka, kung meron namang charge, hindi naman sila nag-move. Yung charge nila. Yung motion, hindi sila paano ko ba didiscuss? Hindi nag-move yung mga charges. Steady lang sila. Steady lang sila. Steady lang sila sa loob ng atom. That's a very good observation. Pero pag nagkaroon na ng field at i-excite na or i-force na yung mga charges para mag-move, ayun, ibang usapan na yon. Kasi kung kuryente lang, kung wire lang yan, hindi naman nag-move yung charges. So walang current. Kasi current is motion of charges. Pag hindi nag-move yung charge, walang current. Kahit may charge yan. Tama ba? Ay, nakuha mo ba, Kyle? Okay. Kahit meron silang charge, kung hindi naman sila nag-move, wala pa rin current. Kasi by definition, current is there's the rate of flow of charges with respect to time. Okay, so let's say we have a conductor na cylindrical yung shape niya. Ayan. So, let's say this is the cross-sectional area at nandito yung mga charges natin nag-move at nag-travel sila at time delta t ng delta x. So, yung displacement ng charges natin from this point going to this point. From yung motion nila from this point going to this point with respect to time is delta x. So kung gusto natin malaman lahat ng charges na nandito sa conductor na to, yun yung n. Okay? At yung total charge natin, ito yung charge density. Okay? So that is per unit volume. So per unit volume yan. So yung total charge, para ma-compute natin yung total charge dito, so kailangan malaman natin yung volume nung conductor natin. Tapos, i-multiply natin dun sa charge density. So yung charge density, depende yan sa material. So syempre, depende yan sa material kung gaano kadami yung charge niya sa isang given volume. Yan. So para makuha natin yung total number of charges dito, yung charge density, i-multiply natin siya ng volume. Pero ano ba yung volume? So kung cylindrical shape yan, so that is yung area times yung length or yung height. So A times delta X. So para makuha natin yung total number of charges, substitute natin siya dito. So therefore, that is the charge density times the area cross section times the length of the conductor. At para makuha natin yung total charge, okay, charge then total total number of charges. Yung total charge naman ng mga charges na yon ay yung total times yung charge ng bawat isa. So let's say kung electron yan or proton, yung charge nila ay 1.6 times 10 raised to negative 19. At para makuha natin yung total charge, kung ilan sila. Okay? At yung total natin is ito siya. So, sinabstitute natin yung ito dito. So, nakuha natin ito. Okay? Yan. Okay. Pero kung kukunin natin ang speed or yung drift speed nung charges natin, so that's equal to delta x over delta t. So, that is the speed. That's length over time. Tama? So, kung kukunin natin ang in terms of length, so delta x is equal to v, the drift speed times time. Kasi substitute natin siya dito. So, we will have this. Okay? So, sinubstitute natin yung delta x dito. So, ito yung nakuha natin. So, we'll have delta q is equal to NAVD delta t times q. Okay, divide natin yung pareho ng time. So, maka-cancel yung time dito. But what is delta Q over delta T? Di ba current yan? Ayan. So, that means current is equal to NAVDQ or charge density times the cross-sectional area times the drift speed times the charge of each particle. So, this is the ng current natin. Current in terms of the drift speed and the number of charges. Okay, so napaka-importante ng formula natin yan. Kaya, pag ni-review natin, ito yung mga formula ang gagamitin natin. So far, ito na yung mga formula na kailangan ninyong i-memorize. Okay, so meron na tayong yung tatlong current, general, the average, and then the instantaneous. And then we have the current in terms of drift speed. And then but drift speed is in terms of length over time. Okay, so pagkatapos ng current, yung namang current density, yan, current density natin, it's J. So ang symbol niya ay J. So that is equal to the current over the cross-sectional area. So let's say I have a wire na meron siyang cross-sectional area. Tapos dadaan dito yung charges natin. So kung alam natin yung current, so we can have the current density, which is A over current I over A. So ang unit niya ay ampere per meter squared. So ito yung SI unit ng ating current density. Ampere per meter squared. Okay? In the current density is in the direction of the positive charge carriers. So we're always considering yung positive charge yung nagmo-move kasi nasa conventional flow tayo. Ayan. So yun yung ating current density. So inaano niya dito kung ano yung current na dumadaan at a given cross-sectional area. Okay, kasi napaka-importante yun sa susunod. Okay, yung conductivity naman natin is ang symbol niya ay yung sigma. So this is like the property of a material which allows the flow of charges dun sa material na yon. So, hindi niya binablock. Okay? So, ina-allow niya. So, parang yung mga conductors, mataas yung kanilang conductivity kasi conductors sila. So, mataas yung kanilang conductivity. So, ang sinasabi din dyan na yung conductivity daw ay siya yung constant of proportionality ng relationship ng electric field at saka ng current density. So yung current density daw is proportional to the electric field. So that means J is equal to, mathematically, so the J or the current density is equal to sigma times the electric field, wherein sigma, that is the conductivity. Yan. So isa siyang property ng materials. So most conductors, mataas yung kanilang conductivity kasi they allow the flow of charges easily. Ina-allow nila yung flow of charges sa kanila. Unlike mga insulators, binablock nila. Yes, Ivan? Sigma. J is equal to sigma. Uh, alpha, that's not the symbol of alpha. Okay. Ito. This one. This is proportionality. Yeah, pag nagsusulat tayo ng relationship ng proportionality, let's say directly proportional or inversely proportional, ibig sabihin natin is proportional siya sa E. So, J is proportional to E. At kung isusulat natin siya ng mathematics, yung proportionality, gagawin natin siyang, alam niyo yung JK. Halimbawa, A is proportional to B. So, A is equal to KB. Kaya nagkakaroon tayo ng proportionality constant because of that one. Formula kanina? Yung summary muna. Yung summary lang. Yan. Okay. So, ayan. So, sinasabi dito, isipin nyo na Joe, ayan, Joe, na yung concept of proportionality ng relationship ng current density at electric field ay yung sigma or the conductivity of the conductor. Ayan, Joe. Okay, bakit importante yan? Kasi, ang sabi ni Ohm sa kanyang law, sa Ohm's law, narinig nyo na ba itong Ohm's law? Mga class? Yan. Okay? Ang sabi ni Ohm, ni George Simon Ohm sa kanyang law, that many materials, the ratio of the current density to the electric field is a constant sigma that is independent of the electric field producing the current. Ayan. Ang sabi ni George Simon Ohm sa kanyang law or the Ohm's law, that the conductivity is equal to the ratio of the current density and the electric field producing current. So, di ba nanggaling din naman siya, related din naman siya dito sa conductivity. So, di-divide lang natin to ng E. So, that's equal to the sigma. Okay. So, yun yung parang original statement ni George Simon Ohm sa kanyang law. Pero ang pinaka-common kasing alam nating Ohm's law is this one. Tama ba? Yeah. Pero ang unang statement niya ay nirelate niya ang conductivity sa current density at saka sa magnetic field. So, si George. So mamaya natin i-anuhin yun. Okay? Ngayon, ano naman ang resistance? Okay, so kung ang conductivity ay meron siyang conductance, which allows the charges to flow freely, yung resistance naman ay baliktad. Okay, nire-resist niya yung current or yung flow of charges. So in a conductor, the voltage applied across the ends of the conductor is proportional to the current through the conductor. So sinasabi niya that the resistance is equal to the ratio of the voltage and the current. Voltage, we call this the potential difference. Okay, the constant of proportionality is called the resistance of the conductor. So that's why V is equal to IR. So parang ito ang mas common na alam ng Ohm's law. Okay? At ang resistance natin, ang unit niya ay ohm, and that's equal to 1 volt per ampere. So 1 VA. So ang symbol ng resistance natin ay ohm. Symbol niya ay ohm. 1 ohm is equal to 1 volt per ampere. Okay, resistance in a circuit arises due to collision between the electrons carrying the current with the fixed atoms inside the conductor. So there's still resistance inside when charges are moving. Parang friction lang. O yan. So yung resistance na yon, o yan, yung tinatawag nating resistance. At yung mga resistors ay mga components na yan na merong resistance. So ginagamit sila para i-limit or i-resist yung flow of charges or yung current. Yung resistance. So halimbawa, kailangan mo ay 5 amperes pero ang meron ka 10 amperes. So parang maglalagay ka ng resistor para mabawasan mo yung current. Okay? So yan yung mga resistor. Mga components lang sila. Electrical component. Sa determine ng value ng mga resistors na meron tayong color coding na susundan. Pero hindi na natin ito pag-aaralan. Okay? Sa lab yun na lang ito gagawin. Supposedly. Yung pag-determine ng value ng resistor na may color coding. Okay. Kung resistance yan, so may kinalaman yan sa resistivity like conductivity. Ang resistivity ay yun yung inverse ng conductivity. So, the resistivity which is rho naman ang tawag dito is equal to 1 over sigma or 1 over conductivity. So, ang reciprocal ng resistivity ay conductivity or vice versa. Okay? Ang resistivity, ang SI unit niya ay ohmmeter at ang resistance is also related to resistivity. So, ang resistance natin ay equal siya sa rho L over A. Rho L over A. Okay, so yung rho, that is the resistivity, and then L is the length of the conductors in meter, and A is the cross-sectional of the conductor in meters square. Okay, so meron tayong iba't ibang klase ng value ng resistivity. Kaya papakita ko na lang, i-review ko na lang. So, ito yung mga values ng ating resistivity. Nandito sila. So, we have these common materials. Ayan. Okay, ano yung may pinaka mababang resistivity? Ayan, sunod-sunod naman sila. Ang may pinaka mababa ay yung silver. Okay, so ibig sabihin, kung siya may pinaka mababang resistivity, reciprocal nun ay siyempre, siya naman ang may pinakamataas na conductivity. So, pwede nating sabihin siguro na yung silver ay siya yung best conductor. Kasi siya yung may pinakamababang resistivity. At the same time, siya yung may pinakamataas na conductivity. Okay? So, yung silver. Okay, ngayon, paano nakuha yung formula na yan? Okay? Paano nakuha ang formula na yan? Okay, sabi sa Ohm's Law, okay, Ohm's Law, okay, ang conductivity daw ay equal siya sa current density over the electric field. Ayan. So kung kukunin natin, kung i-cross multiply natin ang E density over J, ayan, pero ano yung value ng J? So J is equal to I over A at yung E ay manggagaling siya sa voltage is equal to E times D. Okay? So yung D na yan, lumawa, ito yung electric field. So meron tayong dalawang points sa electric field. So yung distance between them is yung D. Okay? So ito yung higher potential. Kaya sa tinawag na potential difference. Ayan. So meron tayong given value ng E at saka yung dalawang point sa E natin. So yung difference ng dalawang point na yan. Kaya yung E natin will be equal to V over D. So, V over D times resistivity is equal to I over A. Cross-multiply natin yung tama ba? Okay, tama, tama. So, i-cross-multiply natin yung I at saka yan. So, yung V over I equal siya sa D over conductivity times A. Pero ano yung ating conductivity? So, that is 1 over resistivity. So, V over I is equal to D over 1 over resistivity times A. Or, itaas natin siya. So, rho D over A. Okay, but D natin ay, tawagin natin siyang length. So, therefore, V over I is equal to rho L over A. So, sabi dyan sa resistance, di ba ang ratio daw, ay, so, masaan? Okay, ang resistance daw ay yung ratio siya ng voltage at saka ng current. So, therefore, this is also equal to R. Kaya R is equal to rho L over A. So, rho L over A. Kaya, class, paano mo, ano bang mas maganda, mataas ang resistance or hindi? Siyempre, ako nag-move or nag-transfer ka ng current from one point to the other, kailangan mo ay mas mababang resistance. Ngayon, paano mo pabababain yung resistance? Una, kailangan mababa yung kanyang resistivity. Pero yung length kasi, hindi naman natin yan makontrol. Pero yung area, kaya natin gawin. Kaya lang, ang ano kasi sa area, yung cross-sectional area, so the more na lumalaki yung cross-sectional area, ano nangyayari doon sa, kasi kung the more na lumalaki yung cross-sectional area, diba, compare natin sa dito. Okay, saan mas madaling mag-move yung charges? Okay, saan mas madaling mag-move yung charges? Yung merong malaking cross-sectional area. Baka sa sakyan ng mga yan, syempre yung motion dito ay mas maganda compared dun sa motion dito. Kaya yung resistance ay bumababa kasi pag malaki yung cross-sectional area. Ayan. So, mas mabilis silang mag-move dito compared to mag-move dito. Kaya lang syempre for practicality reasons, hindi mo naman pwedeng yung wire, kapalan mo yung wire. So, hindi naman yun po pwede. Hindi mo naman pwedeng gawin yon. So, imagine niyo makapal yung nasa poste. Meron naman siyang disadvantage. Siyempre, meron siyang weight. Hindi naman kakayanin ng support niya. Ayan. Kaya, binabawi na lang siya sa ibang bagay. Okay? Siguro, probably sa resistivity, yung papalitan yung material na may mas mababang resistivity para mas maganda yung flow of charges or yung motion ng mga charges natin. Okay? Okay, next. Yan. So, we're done with that. Okay, so parang isa-summarize lang natin. Ayan. So, ang relation ng resistance at saka resistivity, since we have this formula, directly proportional sila. So, that means kung mataas yung resistivity, tataas din yung resistance. Okay, kung mataas yung resistivity, mataas din naman yung resistance. Ngayon, may effect ba ang temperature sa resistivity or resistance? Oo. So, kung merong tumataas yung temperature, ibig sabihin, yung resistivity nagbabago din. So, tumataas din yung resistivity. Kaya pag tumaas din yung resistivity, tataas din yung resistance. Kaya pwede natin conclude na pag tumaas yung temperature nung conductor natin, yung resistance niya ay tataas din. So, yung tatlo kasi ay directly proportional sila. So, para makuha natin yung change in resistivity, ito yung formulang susundan natin. So, the final resistivity is equal to the initial resistivity times the quantity 1 plus alpha times the change in temperature. Wherein yung T dito, that's the T final related to the final resistivity. At yung T natin dito ay related siya sa initial. Okay. So, saan natin kukunin yung alpha? So, yung alpha natin ay kukunin natin siya sa table. Yung table kanina. So, sa table ng resistivity, ayan. So, nandito yung ating mga alpha. Ayan. So, ito yung ating alpha. Ayan. Okay? But kailangan yung i-take note ito na lahat ng values na to ay under 20 degrees Celsius. Kung wala sila sa 20 degrees Celsius, hindi nyo sila agad pwedeng gamitin. So, kailangan kumuha muna kayo ng value using this formula. Okay, para sa new alpha. Okay. Okay, so natin kukunin yung mga alpha natin, but just take note that all values are at 20 degrees Celsius. Okay? So, ganun din ang temperature with resistance. Kung resistivity yon, kung titignan niyo yung formula, okay, pareho lang din naman. Papalitan niyo lang yung resistivity ng resistance. Kasi pag tumaas yung temperature, tataas din yung resistivity at saka yung resistance. At yung alpha na ginagamit dito for resistance is the same alpha na nasa table natin. Table 27.2. So, same alpha din yung gagamitin kung resistance naman yung magbabago. Okay? Okay, so we have discussed current. We have a little bit of voltage. And then we have resistance or resistance. Okay, ang last one natin ay yung power. Ayan. So, yung power natin is given by the equation I times the change in voltage. So, IV. So, applying Ohm's law. Okay, kung mag-apply tayo ng Ohm's law, ayan. So, yung power natin, kasi ang power is equal to work over time. So, that's equal to joules per second or yung 1 watt. Ayan. So, ang power natin ay given as current times voltage, wherein based on Ohm's law, voltage is equal to IR. Kung isa-substitute natin ito dito, so we'll have this other formula of power. Kung baliktad naman, yung I naman yung isa-substitute natin, wherein I is equal to V over R. So, magiging ganito naman yung formula ng power. So, meron tayong tatlong power. Okay, so paano naging watts yan? Ang current kasi ay equal siya sa ampere na coulombs per second. At ang voltage natin, or potential difference na 1 volt, ay equal naman siya sa joules per coulomb. So, cancel natin yan. So, that's still joules per second. And joules per second is equal to 1 watt. Okay? Yan. Before I give you the poll, yes, Ivan? Ito? Pag ang V is equal to IR, isa-substitute natin siya dito. So, magiging I times IR, so I squared R. Kaya siya magiging powers also I squared R. Okay, kung current naman na nanggaling dito, so current naman is equal to V over R. Substitute naman natin siya dito. So, magiging V over R times V. Kaya magiging siyang V squared over R. Okay? Nakuha ba? Okay. Any other question? Okay. Kung wala kayong question, ito na yung question ko. Wala pa man akong tanong, so may sumagot na. Ang tanong ko, ang current, is that a vector or a scalar quantity? Current ba? Ang sabi ng nakakarami ay vector daw siya. Okay? 14 ang nagsabi na vector at 8 ang nagsabi na scalar. So maraming di sumagot. Nasaan sila? Salmer, Oliver, Mary, Lance, Lionel, Angelo, Bernard. Ano yung mga sagot niyo? So, ang tamang sagot ay yan, 16, hati. 16 ang nagsabing vector, 8 ang nagsabing scalar. So, ang tamang sagot ay, okay class, medyo nakakalito siya dahil merong direction yung current. Tama? Kaya lang, ang isang qualification para masabi natin na vector ang isang quantity, kahit may direction siya, na dapat at any point in time, yung direction niya ay hindi nagbabago. Okay? Hindi nagbabago. Pangalawa, kapag nag-add tayo ng mga vectors, kailangan kino-consider natin yung direction. Kasi magbe-vector direction tayo. Pero yung current, di ba, halimbawa, meron ako dito, dalawang wire dito, tapos nakatap ako dito. So, meron akong dalawang current dito. Na ito yung direction ng current dito, ito yung direction ng current dito. So, that means lalabas ng current dito is 3 amperes. Di ba algebra lang yung ginamit ko? Hindi naman ako nag-vector addition. Kaya, kahit may direction ng current, it's still considered a scalar quantity. It is not a vector. Kasi, hindi naman siya sumusunod ng rules ng vector. Kaya hindi mo siya pwedeng tawaging vector kahit may direction siya. Okay? Nakuha ba? Na scalar ang current. Dapat para masabi natin, ulitin ko lang, dapat para masabi nating vector siya, dapat susunod siya dun sa mga rules ng vector. At kung i-add natin sila, so dapat mag-vector addition tayo like polygon method, like component method, or parallelogram. Di ba pag nag-add tayo ng current, ina-add lang natin yung value nila. Hindi naman tayo nag-vector addition. Kaya hindi mo talaga, kahit may direction siya, hindi mo siya pwedeng, oo, iba-iba. Kahit may direction siya, hindi rin talaga siya pwedeng tawaging vector. Kasi hindi naman siya sumusunod sa rules ng vector. Okay? At saka at any point in time kasi, yung direction niya ay nagbabago. Hindi naman siya consistent. Hindi pare-pareho. Okay? Okay. So, wala na. Let's have our first example. Ayan. So, the quantity of charge that has passed through a surface area of 4 cm squared varies with time according to the equation. Q is equal to 10t cubed minus 8t squared plus 3t minus 5, where t is in seconds. What is A, the average current from 1 second to 4 seconds? B, what is the current at t is equal to 2 seconds? And C, what's the current density through the surface at t is equal to 2 seconds? Okay, so unahin na natin ang average current. Okay, so letter A. Ang Q natin ay equal siya sa 10t cubed minus 8t squared plus 3t minus 5. So letter A, what is the average current? So ang average current natin is delta Q over delta T. So that's equal to Q final minus Q initial over T final minus T initial. So, wala naman tayong given yan, but given tayo ng T initial. So, T initial natin ay equal siya sa 1 second. So, therefore, we can get a Q initial. So, substitute lang natin siya dito. 10 times 1 cubed minus 8 times 1 squared plus 3 times 1 minus 5. So, the answer is, pa-compute na lang. Okay? And then, yung T final natin ay equal siya sa 4 seconds. So, therefore, magkaka-Q final tayo na 10 times 4 cubed minus 8 times 4 squared plus 3 times 4 minus 5. So what's our Q initial and then Q final? Tama ba? Kung zero yung initial? Okay, so ano yung final? Okay, ano yung final natin? Okay, parang familiar yung ganyan. Oo, tama. Kung naalala ninyo, yung ating average and instantaneous velocity and acceleration. Ganyan talaga sila. Pareho lang sila. Kaya lang dito hanggang first derivative lang. Wala tayong second derivative. Okay, 519. Tama ba ako? Tama, past lesson natin. Kung naalala ninyo, yun yun. Tama ba ako 519? Okay, so 519 columns. Okay, so that means, substitute natin 519 minus 0 over 4 minus 1. So the answer is okay, 173 amperes. Ayan. Okay, so that is our average current. Okay, so letter B. Ayan. So what's our instantaneous current? Okay, class current. Sinabi instantaneous yan. So that's equal to dq over dt. Ayan. So that gets the first derivative. Derivative nito. So that's 30t squared minus 16t plus 3. Okay? And then, isubstitute lang natin. So, current is equal to 30 times 2 squared minus 16 times 2 plus 3. So, what is our instantaneous current? Okay. 91 amperes. Okay, okay. And then letter C. Okay, what's the current density through the surface at 2 seconds? So, ano ang current natin at 2 seconds? So, fortunately, yun yung sagot natin sa B, which is 91 amperes. Kung hindi 2 seconds, kailangan mag-compute tayo ulit ng current. Magets nyo ba? Halimbawa, sinabi ko what's the current density at 3 seconds, kailangan mag-compute tayo ng bagong current. Hindi natin pwedeng gamitin to kasi pang 2 seconds to. So, mag-compute tayo ng 3 seconds. Okay? 3 seconds. Kaya lang, sa C, 2 seconds din yung tinatanong. So, therefore, eto din yung kukunin natin. Gagamitin natin. So, ang current density natin is I over A. So, that is equal to 91 amperes over yung current natin na 4 cm squared. But convert natin to ng meter. Okay, so the answer is okay, 227,500 amperes per meter squared. Ayan. Yes, Angelo? Para saan yung 2 seconds na nalakay? Sa letter C? Okay? Ah, yes. Tama, tama. Pero kung ang nakasulat doon is 3 seconds, hindi natin pwedeng gamitin yung 91. Kailangan hahanap tayo ulit ng current at 3 seconds. Nagets ba? Yes, iba. Ibang solution nun. Pag, let's say, ibang, hindi 2 seconds yung ginamit na, hindi 2 seconds yung question sa C, ibig sabihin, maghahanap tayo ng bagong current. Depende dun sa time. Okay. Okay? Okay na? Okay, so let's have another one. Try daw natin kunin ang 3 seconds. So, sige, pwede din. So, what if, okay, dagdagan natin yung problem natin. So, let's say letter D. What is J at 3 seconds? So, kailangan mo na natin kunin ng I. So, I is dito din. So, 30 times 3 squared minus 16 times 3 plus 3. Ayan. So, what's the current at 3 seconds? Okay, 225 amperes. So, therefore, so may susulat dito na. Therefore, J is equal to 225 over, i-klase shortcut ko to, 4 times 1 over 100 squared. So, what's our J? Okay, 562 500 amperes per meter squared. Ayan. Okay, let's say that's 3 seconds. Eh, nagkataon kasi na yung C related siya sa B. So, mas madali siya para sa atin. Okay? Okay, so let's proceed to next example. Ayan. So, a current of 5 amperes exists in a 10 ohm resistor for 4 minutes. How many coulombs and electrons pass through any cross-section of the resistor in this time? So, ang given natin, a current is 5 amperes, okay, resistance is 10 ohms, and then the time is 4 minutes. Ayan. So, una, ang hinahanap natin is the charge. So, what is the total charge? Now, how is charge related to the given? So, meron siyang relation sa I and T that I is equal to the charge over time. So, therefore, charge is equal to Q times, sorry. Mali ako ng sulat. So, Q is equal to I times T. Ayan. So, therefore, Q is equal to, what's the current? So, 5 amperes times the time na 4 minutes. But convert that into seconds. So, for every 60 seconds, we have 1 minute. Ayan. So, what's the total charge? 5 times 4 times 60. So, that's 1,200 coulomb. So, 1,200 coulomb. Okay. Letter B. Ang question naman dyan sa B ay, ilan namang electrons yon? Okay, ilang electrons yon? So, naalala niyo yung Q total natin on the quantifying of charges? Okay, so na yung Q total equal siya sa number of charge times the charge of each. Ayan. So, yung number niyan is equal to Q total over yung charge of each. So, that's equal to 1,200 coulombs all over, okay, for every, for 1 electron. So, meron tayong 1.6 times 10 raised to negative 19 coulomb per electron. Ayan. Coulomb per electron. So we can cancel yung coulomb. Tapos itataas natin yung electron. Ayan. So what's the number of charges? Okay, 7.5 times 10 raised to 21 electrons. Yung iba, ang ginagawa nila is nagko-convert na lang sila. Halimbawa, ang 1, 2, column, multiply mo ng for every charge, meron kang 1.6 times 10 raised to negative 19. Okay, so, siya din naman. Cancel, column. Hindi ko na sinama yung negative kasi number yung tinatanong. Ilan yung electrons? Tama ba ako? Ilan yung electrons? Ilan? Saan galing yung one? Yun yung charge nung electron and proton. Yeah, that's the charge. Yes, constant yun. 1.6 times 10 to the negative 19. So that's the charge of either an electron or a proton. Yeah. Okay, now let's have this next example. Okay, a rod of 2-meter length and a square cross-section is made of a material with resistivity of 6 times 10 raised to negative 8 ohm meter. If the potential difference is placed across the ends of the rod, what is the rate in heat generated in the rod? Okay? Okay, class, so heat is related to energy, or heat is an energy. So energy dyan, ano ba yung rate? So rate means it's over time. So that means ang hinahanap natin ay power. Yan, power. Okay, so ang ibang given natin, ang length ay 2 meters at yung area ay 2 millimeter by 2 millimeter. Na square kasi siya. So ito yung area natin. And then yung resistivity is 6 times 10 raised to negative 8 ohm meter. And then the voltage na 0.5 volts. Ayan. So itong tatlong ito ay related sila sa resistance, and this one is in voltage. So meron tayong unit ng power formula na V squared over R. Ayan. So given na tayo ng V, kailangan na natin kunin yung R. Okay, so ano ba yung R natin? So R is rho L over A. So that's equal to 6 times 10 raised to negative 8 ohm meter times 2 meters all over. So yung area natin ay 2 millimeter by 2 millimeter. So convert natin yan na 1 meter is equal to 1,000 millimeter. So square natin kasi dalawa sila. Okay, so what is our resistance? It is 0.03 ohms. So therefore, power is equal to 0.5 squared over 0.03. So power is equal to 8.33 watts. So the answer is letter C. Okay? Okay, so let's proceed to another one. Okay, so the electron density in copper is 8.49 times 10 raised to 28. So N is equal to 8.49 times 10 raised to 28 electrons per cubic meter. So the electron charge is, ayan. So ito yung sinasabi ko kanina. So given naman yan, that each charge is 1.6 times 10 to the negative 19. So when the current is 1 ampere present in the copper wire and the 0.40 cm squared cross section, so area is zero point 0.4 cm squared. The electron velocity is, so ang tinatanong ay ano ang VD? Ano ang VD? Okay, so ano ba yung formula natin with nakasama ang mga to, di ba? I is equal to NA VDQ. So that means VD is equal to I over NAQ. So that's equal to 1 ampere all over 8.49 times 10 raised to 28 electron per cubic meter times the area of zero point 0.4 cm squared. Multiply that by 1 over 100 squared times negative 1.6 times 10 raised to negative 19. So what's our drift speed? Drift velocity. Okay, negative 1.84 times 10 raised to negative 6 meters per second. Okay, so the answer is letter A. Okay? Okay, may question? Okay, can you try this one? The next one. Can you try the next one? Ayan. So what? Okay, so by the formula, R is equal to rho L over A. So given that the length is 1,000 and then the resistivity of copper is 1.7 times at 10 raised to negative 8, and then the diameter is 4 millimeters. So that's equal to the L times length, and then area is, since diameter yan, so pi d, uh, pi d squared over 4. So pi over 4 times d squared. But we need to convert millimeter into meter. So the resistance is 1.35 ohms. Okay. So let's have another one. So ito yung question. So a fuse in an electric circuit is a wire that is designed to melt and thereby open the circuit. If the current exceeds a predetermined value, suppose that the material to be used in a fuse melts when the current density rises to 440 um, ampere per cm squared. So that's our current density. Now 440 ampere per cm squared. What is the diameter? What diameter of cylindrical wire should be used to make a fuse that will limit the current to zero point 0.5 ampere? So given tayo ng current na zero point 0.5 ampere, ano daw dapat yung diameter? Okay. And anong relationship ng dalawa ba? So ang J ay equal siya sa I over A. Ayan. So anong relation ng A sa D? So that's equal to I over pi over 4D squared. So that means, gagawin natin to get D. So therefore, D squared is equal to I over pi over 4J. Cross multiply lang natin and then square both sides. So D is equal to the square root of I over 4 over pi J. Okay, so that's equal to the square root of 0.5 over 4 over pi times 440 ampere per cm squared. Cancel yung ampere. So, ang D ay equal siya sa 0.04 cm. Okay, or para masyadong ano naman yan. Or ano na lang. Or 38.04 times 10 raised to negative 3 cm. Yan, para mas exact yung value. Okay, any question? Okay, so let's have another example. Ayan. So a wire of nichrome, 1 meter long and 1 millimeter squared in cross-sectional area. It carries a current of 4 amperes when a 2-volt potential difference is applied between its ends. Calculate the conductivity of nichrome. Ayan. Okay. So ano ang given natin? So it's the length is 1 meter and then the area is 1 millimeter squared and then the current is 4 amperes and then the voltage is 2 volts. So tinatanong ay ano ang conductivity. So wala tayong direct formula for conductivity but we know the relation between conductivity and resistivity, that resistivity is 1 over conductivity or conductivity is 1 over resistivity. So that means if we will get the resistivity, we can find the conductivity. Okay, saan natin kukunin yung conductivity? So, dito, resistivity. So, dito. So, una, so given tayo ng voltage and current, di ba ang resistance ay V over I. So, that's equal to 2 over 2 volts over 4 amperes. So, therefore, meron tayong 0.5 ohms. Next, di ba, ang resistance is rho L over A. Okay, so kailangan lang natin ito. So, therefore, resistivity is RA over L. So resistivity is equal to 0.5 ohms times 1 meter all over, area pala. So area is 1 millimeter squared multiplied by 1 meter over 1,000 millimeter, then square that all over the length of 1 meter. So what is the resistivity? Okay, 5.0, 5 times 10 raised to negative 7 ohm meter. Ayan. Therefore, ang conductivity natin is 1 over 5 times 10 raised to negative 7. So, conductivity is 2 million or 2 times 10 raised to 6 ohm meter raised to negative 1. Okay? Okay, class. So, any question?